Hi, my name is Chuck McCullough, and welcome to episode 2 of our live stream on C++ programming. Let's jump right in. Today, we're going to be learning a number of different things about programming in C++. So today, I'm going to show you how to create, build, and run your program in Visual Studio Community and also in Visual Studio Code if you have a Linux system. We're going to do a little bit of information about the basic syntax, but not cover all of it. We're also going to learn how to write basic information to the console, read some user input from the console, perform some basic arithmetic, and also that word type that we talked about last time, a little bit about type conversion as well. All right, let's start with Visual Studio Community. We're going to start by start Visual Studio Community, and then we're going to select the option to create a new project. And we're going to pick for our language C++ in this little filter box at the top, and console for the project type. There should be an option to select console application. Then simply hit next, give your application a name, choose a location for it, give your solution a name. Let's just call our solution C++ exercises. And let's name the project episode 2. You can also pick a location for your application as well. The console application project comes preset with some starter files to kind of help you get started to avoid some extra steps. So it gives you a bunch of comments. These double forward slashes are comments. That's just plain text. It doesn't have an impact on our program. You can delete that stuff if you wish. We have a little bit of code already here, a pound include, a main, etc. We'll talk more about that in just a second. As far as the project is concerned, your solution in Visual Studio Community is just a container of projects. It has no meaning beyond that. We can put multiple projects within the solution. A project simply means we're producing a single output that we can execute. So no matter how many source files we have within that project, they all contribute towards a single program that we can execute from the command line, or in this case, from inside Visual Studio Community. You'll notice that you have a couple of folders here. These aren't real folders. They're just categories within this Solution Explorer. And there's our one file, episode2.cpp. We are typically going to name our files with a .cpp extension if they're part of the Visual Studio environment. Inside, we have the pound include iostream. We'll talk more about that later. For now, this will be a boilerplate. This will be the template that we use for all of our projects whenever we create an application. We're always going to have pound include iostream. We're always going to have int main open close parentheses, curly braces, and then some type of standard : cout. And I'll explain all of that in just a second. Next, let's talk about how to do this in Visual Studio Code. Okay, for my Linux users, remember, you've already installed Visual Studio Code. If you haven't, check out the link above where I talk about that in episode 1. You can review that real quick. So in your Linux environment, just create a subdirectory somewhere that you are going to use for this project. It can be an empty directory. Notice I don't have anything in here. And I'm going to just type in code and then dot to say I'm opening code on this current directory. Visual Studio Code will launch. And I'm going to choose to create a new file. And I'm going to name this episode2.cpp. Based on the extension, the CPP extension, it's going to create that file for me. And it's going to use C++ rules or C++ extensions for this. Now, I don't get the starter boilerplate code, so I'll have to type this stuff in. So we're going to do a pound include on iostream. And then int main open curly brace std : cout, and then a semicolon. Now, to build and run, we'll go back to the command shell. this tool saves automatically every few seconds. So the file should be there in our local directory. So let's jump back over to our Linux command shell. Let's do a dir. There's episode2.cpp. To compile this, we will run g++, followed by the name of the file that we're going to compile. I'm just going to put star.cpp. I can do wildcards here. And -o for what I want to name the output file. And I'll use .exe, even though that extension is not required in Linux. Let's do a directory. There's the file. So to run it, /episode2.exe. And there's my output. You can see it right over here. It came out and there was no new line there. So the command prompt is at the end of it. Let's add a new line real quick, because that's what we had in the other project. I just forgot to do it. Standard : ENDL. Do the build again and then run it. That looks a little better. There's our output. Okay, so those are the basics. Now, for you guys that are using Visual Studio Code, there is a way to build and run from inside the integrated development environment. There's a little play button here. You can see it up here. If you click on that, it will build and run. Now, it has to be told how to do that. So the first time you do it, it's going to say, I don't know how to do that. Do you want me to create a task.json for you based on the language that you're using? And you probably aren't going to like the one that it creates for you by default. So you can tweak around on that a little bit. We are not going to go over how to do that in today's lesson. I'll point you to some other resources, or you can Google it to find out some options for task.json. We'll go into it in a little bit more detail in future classes when our projects are a little bit more complicated. All right, so let's go ahead and talk about some C++ stuff. Let's talk about some basic syntax rules and continue on with our class. All right, let's talk just some basics, very basics. I'm not going to get into too much detail here, but let's look at a few things that we've got in our code already. First thing, this #include for IOStream. IOStream is a file, we call it a header file. It is part of the standard C++ library. You can find this file wherever your C++ was installed. We need to include this file. It becomes part of this compile unit because the symbol cout is defined within that file. We can't use something unless it's defined already. And cout is not a built-in keyword in the language. It is actually a global variable that is declared inside IOStream. Cout represents the standard output device. It represents the console. So whatever we insert into cout or stream to cout will appear on the console. This std : prefix is a namespace. Everything in the standard library is part of the standard namespace. Namespaces are there to help us avoid having duplicate symbol errors. There's a lot of symbols defined within C++, and when we get into third-party libraries, there are even more. You could have thousands and thousands of symbols as part of header files that you include in your program. You're also going to define your own symbols, your own variable names, function names, and so forth, and the likelihood of a collision of having duplicate symbol names is very high. So we use namespaces to put those symbols into different sections so that they are qualified by some additional text to make them less likely to be a problem. Everything that's part of the standard C++ library is in the namespace standard. To avoid having to type in std : in front of everything, I'm going to add a using statement. I'm going to say using namespace, std : For everything after this statement in this source file, the std : prefix is implied. So anywhere that I want to use something from that namespace, I don't have to put that prefix on the front of it. Now, if I have several using namespaces for different things and they have duplicate symbols, I will be back in the same problem where we have a duplicate symbol error. Cout, as I mentioned, is the output stream, the standard output device, our console. The what we call the left shift operator, or in the context of cout, it is the inserter. It inserts whatever the next parameter is onto that output stream. In this case, a character pointer or a string, some literal text, and indel, also a global variable defined in IOStream. If I hover over, you can see it gives me some information about that. It says writes a new line and flushes the stream. Okay, so that's what that does. Now, when we run the program, that's what's going to happen. A couple of more things syntactically. Main is what we call a function. Functions look like this. They have a return type. What's the result of executing? What do we return to the caller? We're actually not doing that. That's a bit of an error in this case. And what is the name of the function? In this case, main. What parameters are being passed into main? In this case, nothing. Actually, technically, we're supposed to pass in an array of strings and the number of strings in that array to main. We'll talk more about that later as well. Following the name of the function, the return type, the parameter list, we have the body of the function. The body of the function is enclosed in curly braces. For now, this will just be a boilerplate. Take my word for it. We'll talk a lot more about functions later on. So every time we do a lab for today and the next episode or two, we're just going to create main. We're going to go ahead and put the using namespace in and the pound include for IOStream. That will get us started for the various things we're going to do going forward. This cout is what we call a statement. Just like a sentence in English, it has a grammar, it has a syntax. And like a sentence in English that ends with a period, in C++, our statements end with a semicolon. So the compiler knows, the language knows we're finished with that statement because it reached the semicolon. It doesn't care how we organize this code. I can put everything on separate lines, and it still means the same thing. It knows we're done because we hit the semicolon. If I want to do something else, if I want to have a different statement, I can write another cout, and that's another statement. C++ is also case sensitive. It makes a difference whether I use cout with all lowercase or cout with some uppercase letters in it. You'll notice that I have a squiggly underscore now on cout because it says it doesn't know what that is. It is case sensitive. Cout does not start with an uppercase C. It starts with a lowercase c. By simply hovering over the squiggle, I can see the error message. In some cases, it might offer a quick fix for me. If you're using Visual Studio Community, there'll be a little light bulb pop up when you do that. So maybe I don't have the right include file that contains the definition of that symbol. I might even, in Visual Studio Community, it might even suggest that I change the spelling to use a lowercase c to indicate that. All right, so we can write something else. And this will just literally be written to the standard output device, followed by a new line. Let's jump back to the console, build, and run. So you can see our new output. So that will be our process. Now, we can do the same exact thing in Visual Studio Code. I'm just going to copy and paste this. We'll jump over to Visual Studio Code. I'll dump that content. We just do a little bit different thing for running. Here we will run by clicking on the little play or run button up at the top, and that will build. So you see the build happen. Whoops. No, I do not want to run. I forgot to do the using namespace. Now we can build and run. So the compiler runs in this little output window below, just like it did. We just have it inside Visual Studio, but it still actually opens the equivalent of a command shell, and it runs not G++, but the Microsoft Visual C++ compiler, MSVC. It's also a standards-based compiler. It is compatible with C++ 20. So you can see the same output in this little console window that opens up temporarily. We can press any key to close that. Same thing here if we have a syntax error. If I use something that's undefined, we get the little squiggle over it. It will tell me that it doesn't know what that is. And sometimes I might get a suggestion with a little light bulb to suggest something different. All right, so that's how we build and run in our two platforms. We know how to use cout. We know how to do pound include iostream. We now know using namespace standard to shorten the reference to cout and to endl. And we know how to write things to the standard output device. We can also write multiple things. These can be chained together as much as needed. We can put as many left shift or inserter operators and chain a whole bunch of these things together as much as you'd like. And we do have some code style guidelines. We kind of like to have all of this on one line. Unless it won't fit, then I'll put it on multiple lines. It is important to keep the code kind of neat and make it readable for other people that are going to be looking at it, as well as for yourself when you look at it after you've slept. So let's say that we wanted to create an application that calculated the area of a circle. So we think about what are the data points, what do we need, and what are those data types of those data points. So let's say that we have a radius of the circle. So that could be a whole number. That's definitely a number. Is it a whole number? Is it a fraction? Do we want floating point capability or whatever? How much precision do we want? We also need to know what pi is, and we'll have the result of calculating the area. We also want to know the circumference of the circle. So that's another data point. And again, what data type do we want? Whole numbers? In that case, choose int. If you want some precision with float, use float or double. All right, so let's say that we want to use double for all of that. Now, let's jump back over to our code. All right, so I'm just going to wipe out what's inside of main, and we're going to just repurpose. We'll reuse this little bit of code here. All right, so I'm going to declare my variables, and to hold the radius and the circumference and all that kind of stuff. So I'm going to make that a double pi, and I'll paste in what pi is. We'll create a variable to hold radius and set that to 6. And then I'll calculate my area, which is pi times the radius squared. I'll calculate the circumference, which is 2 pi r. And then let's output all of the values, right? And display the area and the circumference of my circle. All right, now this, like I said, auto saves. So let's bring up the console and let's compile. This time I'll do my output as areas.exe using -o. And let's run it. And the area of the circle with the radius 6 is about 113. And the circumference is about 37. I think that's probably correct. I hope it is. If it's not, we're in trouble. What if we wanted to prompt the user for the radius? So let's just declare our variable radius, but not initialize it to anything. We know how to write stuff out to the console, and we know from last week's lab that we don't have to put the new line. So let's just output enter radius and put a space so that the cursor will not be right up against it. And this time, don't put the new line, don't put the end line. Now we're going to use the converse of cout, which is an object called cin. That is the standard input device. And we're going to extract from these right shift, these double greater than symbols means extract from, and we are going to extract directly into our variable radius. extract directly into the variable radius. Now, there's some type conversion here because when the user enters stuff, that's text. The user is actually entering a string. We hope it's a string of digits. We hope that it's a valid floating point number. It might not be. So there's a type conversion because the variables type is a double precision float. C++ is behind the scenes automatically converting that for us. So that built okay. So let's run it again real quick. And this time it prompts me. So let's say the radius is 10. I hit enter. The area is 314 and the circumference is about 62. So that is correct. I think that's correct. Looks correct to me. And so that's our writing a little code, writing a little program that does something. We are prompting the user to enter a value. They have to enter that on the console. We are multiplying it by implementing our formula, which we tested first with hard-coded. So a couple of syntax rules here. First of all, asterisk means multiplication, plus means add, minus means subtract, and the / is divide. In the context of a input or output stream, the less than symbols stacked like this means insert into that output stream, and the greater than extracts from that input stream. You'll see lots more on this as we continue through our course on learning C++. Well, folks, that brings us to the conclusion of this week's session. We've written a little program in C++. We've done some computation. We've declared some variables. Next week, we'll expand our knowledge by introducing the concept of functions, where we will encapsulate some of that algorithm inside of those functions so that we can simply call them. We want to know the area of a circle, just call the function and it'll do it for us. That way it's reusable and we can write whatever kind of application we wish. Hey, thanks for joining our session today. If you're watching this on the replay, that's great too. Welcome. Don't forget to subscribe and look for our next session next week about this time, Wednesday of next week. I'm Chuck McCullough. Have a great day.